My name's Guillermo, and I currently wear multiple different hats, and one of them is co-founder of a group called Humans to Venus, which has a fairly ambitious long-term vision of helping humanity become a multi-planet species with a specific focus on one destination, Venus. Now, if I'm going to be talking with you about having humans living and working in the Venusian atmosphere, which sounds outlandish, literally and figuratively, I think it would help you to know a little bit about my background so you know kind of how to filter my remarks. Probably like many of you, as a kid, I wanted to be an astronaut. And probably like many of you, my life didn't turn out that way. I ended up not becoming an astronaut. And instead, my life took a lot of different turns, and I ended up having what I call a series of micro careers. Basically 3 or 4 years, maybe 5 years in different directions. So over the course of my life, I've been an economist, I've been a lawyer, I've been a military officer, I've been an ocean explorer, and I've been, I guess you'd call it a startup guy. Over the last 25 years, I've helped launch over a dozen for-profit ventures and nonprofit organizations, starting in Silicon Valley, then spreading out throughout the US. I've also worked in Latin America and in Europe. But one key thing to know about me, and it's relevant for this talk, is that I'm not really a subject matter expert in any of the things that you'd normally think of in a startup. I'm not a salesperson, I'm not a technologist, I'm not a finance person. But what that means is that I've had to get really good over the years at bringing together people who know a lot more than I do and who have a lot more experience than I do. And the reason that's relevant for these remarks is what I'm going to be telling you today is not necessarily my opinion. I'm basically synthesizing for you 4 years of discussions with subject matter experts all over the world. Scientists, technologists, investors, government officials, all sorts of people. So with that as background, maybe one more. I said I was wearing multiple hats. This is just a sampling. I'm currently an advisor to a couple of space-focused venture funds, including Raphael's E2MC Ventures. I'm helping to run a nonprofit organization that's setting up a space venture studio. And I'm also currently co-founder of a number of different ventures, including an ocean exploration company, a space mission finance company, a music-focused media company, and then, of course, Humans to Venus. Okay, so with that as background, I figured I'd start by answering the first question that I always get: why Venus? And I was kind of laughing listening to Raphael's presentation, because you're going to see the inverse of his presentation in my presentation. So first of all, if you think about making humanity a multi-planet species, that by definition means we're going to be leaving the comfort of our home world, leaving the comfort of planet Earth. The second we leave the surface, actually the second we leave the atmosphere, I guess, we're going to have to deal with a lot of environmental issues that are out to kill us, right? We're going to have lack of food, lack of water, lack of breathable air. We're going to have to protect ourselves against radiation, temperature, pressure. But the most critical of these is probably gravity. And there's a lot of reasons for that. Now, as you already heard from Raphael, here on Earth we experience 1 g of gravity, right? This is really a function of a celestial body's mass, size, density. So when we go to the Moon and Mars, since they're smaller than Earth, we're going to experience much less gravity there, roughly 17% on the Moon and 38% on Mars. So why is that an issue? Well, almost for the inverse problem that Raphael's company is trying to solve. One big problem with this is that this is the one environmental issue that we do not currently know how to control. Yes, we know that if we theoretically build a big space station and we start rotating it, we can create some artificial gravity. But that's not going to help us on the surface of the Moon or Mars. So when we go there, we're going to be stuck with the 17% and 38% gravity. Now, why is that an issue? Well, one issue is that even in our extensive experience with human spaceflight over the last few decades, we know that even going up to the ISS or microgravity for 6 months or up to a year, we start experiencing some health issues. So we don't know how our body's going to react when we're going for years or permanently or multi-generational. But the bigger issue is when you're talking about making humanity a multi-planet species, you are talking about multi-generational, which means you have to reproduce. And that's one thing that today we don't know if Homo sapiens can actually reproduce in less than 1 g of gravity. We don't know if we can conceive, we don't know if we can carry a fetus to term, we don't know if we can deliver a healthy baby, and we don't know if that baby can grow into adulthood and do it all over again. Now, hopefully, we can. Hopefully, Homo sapiens can do all this stuff in less than 1 g of gravity, especially on Mars, which is so far away, we really can't come back to have babies and go back and forth. So hopefully it all works out. Or even if we can't do it, hopefully the medical community will come up with ways of helping us do it, right? But as of today, we're not sure if we can reproduce, which means theoretically, humanity could be barreling out to Mars and then die out within 1 generation because we can't reproduce. So regardless of all of that, it would be nice if there was an alternative, something that was closer to Earth's gravity. And since gravity is a function of size and mass, it seems that Venus would be a good potential alternative because it is basically 98% of Earth's gravity. So as Raphael's trying to get away from gravity, I'm actually trying to get to gravity, right? So the other way around. So why, if this is all true, why isn't humanity trying to go to Venus? Why haven't we been doing this for decades? And there's a number of reasons for that. I think the number one reason is that when we think about making humanity a multi-planet species, we think about landing on a surface. So we think about landing on the surface of the moon, landing on the surface of Mars. But we cannot land on the surface of Venus. Okay, for those of you that know Venus, it's a hostile environment, and on the surface, the pressure and the temperature would kill us in seconds. Right? The pressure is the equivalent of being underwater about 1,000 meters, and the temperature is hot enough to melt lead. So there's no way we're going to be landing on the surface of Venus. But what about the atmosphere? It turns out that at about 50, 60 kilometers above the Venusian surface, there's a thin band in the atmosphere where the pressure is roughly 1 atmosphere, which is sea level here on Earth. And the temperature is 30 to 50 degrees centigrade, which is certainly hot, but it's not fatal. On top of that, the atmosphere is so thick that the band that's left above it is still providing sufficient radiation protection, even though Venus is closer to the sun and does not have a magnetic field. On top of all that, there's other advantages to Venus. Venus's orbit, first of all, Venus is closer to Earth than Mars is. It's the closest planet we have in our solar system. And the orbits are much more aligned. They're both roughly circular orbits, as opposed to Mars, which has a more elliptical orbit. And so there are certain windows that you have to take in order to launch to catch the planet as it whips around. So with all of that going for it, it's easy to envision a future where we're living in cloud cities on Venus, right? But in order to get there, it's probably going to take centuries to get to something like this that looks, in fact, I think this is from Star Wars Episode 5, right? And I think whenever I talk with people about living in the clouds of Venus, that's the first thing they say. You know, it's the cloud city in Star Wars. And yeah, that could be where we end up, but it's going to take centuries to get there, I think. But in the meantime, with technology that we have today, we could potentially go to Venus in the atmosphere and set up small habitats or interconnected habitats. In fact, these renderings here are from a project that NASA did a few years ago called HAVOC. They love their acronyms. HAVOC, the High Altitude Venus Operational Concept. So it is possible even today to go do this. Now, I don't want to make it sound like it's all easy to do, because there's still at least 2 very major challenges with being in the Venusian atmosphere. Challenge number 1 is that the atmosphere is primarily CO2, so it's not breathable air for us. And challenge number 2 is that in that band of 50, 60 kilometers, there's a layer of clouds that are made of sulfuric acid, which is also not good for us. Now, the good news on that, though, is that we currently have technologies that can turn CO2 into breathable air, and we have technologies that can resist the toxicity of sulfuric acid. So it's not like we've got to wait for the invention of a warp drive or transporter beams or anything like that. It's something that we could work on today. So this kind of leads to the inverse question, which is, why not Venus? right? If we're seriously going to entertain discussions of expanding humanity out into the cosmos by going to the moon and Mars, why not also include Venus in that discussion? It's just as viable, if not more viable, destination as any of these other ones. So we're not saying to stay away from Moon or Mars, we're saying just include Venus in the discussion. That's usually where I end my remarks, but today I'm gonna take one next step. I'm gonna talk publicly for the first time about something we've been working on, which is a question that a few of you asked me today, which is, okay, if we start talking about this and start taking it seriously, what are some of the next steps that we could take to push humanity in this direction? So that requires a little bit of context, and we've talked about it a little bit. Most of you probably realize that, for the last, couple decades or so, humanity's plan for expanding into the cosmos has really kind of followed NASA's Moon, Mars, and Beyond kind of concept. Actually, I guess more accurately, it's LEO, Moon, Mars, and Beyond. And the thought behind this is kind of to create like a staircase approach of developing operational and technical capabilities. You can kind of look at it as a crawl, walk, run kind of approach, which I know there's detractors for this, and critics, but it does make sense. You're going to kind of de-risk everything as you go. You're going to start building capabilities in the relative safety of our own atmosphere, or right above our own atmosphere. Then we're going to go into our planetary backyard, the moon, and try out certain things. And then we're going to finally get to go all the way out to Mars and start doing this. This is important to de-risk this because at some point you're going to have human lives involved, right? So this approach makes sense. The thing is that if you're thinking about going to Venus in the Venusian atmosphere, the operational capabilities that we're going to need to develop to establish a human presence in the Venusian atmosphere are not necessarily developed or helped or supported by Moon, Mars, and Beyond. So for example, the very first thing we've got to do is learn more about the planet Venus. We have very, very little data about Venus, and everything that I'm telling you is just based on just a few missions that the Soviet space program did a few decades ago. So we need to send more science missions to Venus and collect more data before we can do anything else. And by definition, if we're going to send scientific missions to Venus, we're by definition we're outside the Moon, Mars, and Beyond paradigm. The second thing, this capability actually kind of overlaps a little bit with Moon, Mars, and Beyond. This is the only one that overlaps, which is, if we're going to have people living and working in the Venusian atmosphere, we have to get them to and from Venus. So we have to get good at interplanetary human spaceflight. No human has ever flown beyond the relative safety of the Earth-Moon system. So yes, going to Mars would help us develop that capability. The irony, though, is that because I was saying earlier that Mars is further away than Venus and the orbital dynamics are different, you could almost argue that it should be the other way around. We should develop the interplanetary human spaceflight capability by practicing going to Venus first before we take the big leap and go out to Mars. So again, there's kind of a challenge with this Moon, Mars, and Beyond paradigm and how it applies to Venus. This capability is actually the most interesting one, I think, because not only do we have to get humans to and from Venus, we have to get them to and from the atmosphere. So we got to drop from orbit down to the atmosphere and then get them back up. Moon, Mars, and Beyond are all about landing on a surface. So they're going to be landing on the surface and then taking off from the surface. They're not, by definition, going to be developing capabilities to get from orbit down to an atmosphere and then back up. So again, it falls outside of that paradigm. The interesting thing on this one is that the best test bed for this may actually be on Earth here, using our own atmosphere as a test bed going back and forth in orbit. And the last three all have to do with essentially atmospheric chemistry. Three things that we need to figure out how to get done. And because it's atmospheric chemistry, you can already tell by definition, Moon, Mars, and Beyond is not going to help us. One I've already mentioned, which is we have to get good at converting CO2 into breathable air. Number two, we have to figure out a way of extracting drinkable water from the sulfuric acid clouds. And number three, we have to figure out how to extract the right minerals out of the atmosphere to be able to create structures that are resistant to the toxicity of sulfuric acid. Now, fortunately, all of that's theoretically possible. So again, we don't have to wait for the invention of the warp drive and all that stuff. But we do have to figure out how to do it at scale and in the Venusian atmosphere. And I know I'm grossly oversimplifying what it's going to take to do this, right? But that's not really my point. My point with this is that a lot of the core capabilities that we as a species are going to need to develop to exist in the Venusian atmosphere are not served really by the Moon, Mars, and beyond paradigm. Now, I have to be very clear about this, and I say it every time, and if you take one thing away from this, just make sure you get this, which is I'm not advocating for dismantling Moon, Mars, and beyond. I'm not advocating taking money away from these projects. In fact, I think we've spent 20 years developing momentum in this regard, and we're really at a kind of a tipping point with getting back to the moon and then starting to be able to finally look beyond to Mars. And I think it's something that's critical for the long-term success of the species, and we have to keep pushing on that front. However, I do believe that it's possible to create a similar roadmap and a similar path for Venus and run them both in parallel. Now, I'm not naive enough to think that NASA's going to do this, right? Because NASA's funding is so entrenched in the Moon, Mars, and Beyond program that it's going to be very difficult to turn that ship or to expand and get more funding into NASA to do any of this. Which means that there are probably two alternatives for how this parallel effort is going to be done. One is that another national space agency and its international partners takes this on as their mantra over the next decades and leaves the Moon, Mars, and beyond to NASA and its international partners. The other alternative is the main reason I'm here, which is I think it could potentially be the private sector that does this. Basically a global ecosystem of private companies, of universities, of nonprofits that work together to get this done over the next few decades. Someone else asked me today earlier about, well, is anyone working on this stuff already? Well, no one's working on this yet because no one's even talking about Venus as a potential destination, and no one's thinking that it can be done in parallel. But the next step is there's no roadmap. You know, we've got a pretty well-established roadmap, roughly speaking, for Moon, Mars, and beyond, but there's no roadmap for Venus. So one of the things that we're doing right now with the Humans to Venus Foundation is we've got a global community of about 300 subject matter experts that's putting together a rough roadmap that we hope to publish, hopefully by October, and put that out to the world and have people start looking at it and start co-developing it with us, or actually just get them to co-develop it amongst themselves, so that companies and universities and space agencies and nonprofits can look at the roadmap and say, ooh, I want to tackle that problem, or I want to tackle that problem, or I want to take on that opportunity. So hopefully this time next year, if you guys have me back, I can give you an update on actual work that's being done to make this a reality. So that's all I have. I just wanted to kind of put those ideas in your head, and you can start thinking about some questions. As Raphael said, we're going to have Q&A, I think, after Kelly's talk, right? And then, and you'll see when Kelly gets up here, she's going to tie into a lot of these themes as well. So I think it's a good way to end the day. So where's Igor? There you are. Am I done? Excellent. Cool. Thank you.